This is question 5 in our FRQ packet. The original question came from the AP Statistics Exam 2009 Form B. Question 2, if you want to check, if you want to read the scoring guideline in more detail. For part A, so it has a bunch of information about the test, gives you a bunch of numbers. When a new blood sample arrives at the lab, it will be tested to determine whether HIV is present. Use the data from the training program. Estimate the probability the ELISA will be positive when it is applied to a blood sample that does not contain HIV. So that's a conditional probability. We know the blood sample does not contain HIV. So we're only going to look at the ones that don't contain HIV, and we want to know the probability they get a positive test. So the best way to do this problem is to create a table like I did here, like so. So it's 37 out of the 500 is the probability you would get a positive result from a negative person. It's the same thing they got. So let's check what was required. Essentially correct if the student writes the correct fraction for the estimated probability. So there's my correct fraction. That's considered my work and my answer. So if you left it as 37 over 500, you're good. If you only put 0.074, you would not be good because this part right here is your work. Part B. Among the blood samples examined in the training program that provided ELISA results for HIV, which proportion actually contained HIV? So we're looking at the ones that tested, that gave you positive test results. So I want my test to be positive. So that's why I have 526 as my denominator. And of those, which one had 489? Or of those, which ones were actually positive? So it's 489 over 526. For this one, this is like an actual or a true positive test would be what this is called. Versus the first one was a false positive. I don't know if true positive is a correct medical term, but false positive definitely is. Partially correct if the student, essentially correct if you have the correct fraction, or if you give the decimal with justification, justification is the fraction. So the fraction, again, in this case, can count as your work and your answer. Just the decimal would be partially correct. Oh, actually, it doesn't say that. So none might be just incorrect. Well, probably not. But if you made a mistake but you got the correct numerator or denominator here, they did give you partially correct. So I have 2 E's so far. Part C. Okay. All right, on this one, it looks like I messed up. No, I don't think I did. Oh. This should be 489. So I had the right idea, but I did make a mistake here because we are looking at the ones that don't contain, no, not 489. They don't contain HIV. This should be 463. Yes, should be 463. I just did the wrong fraction because I should have been using this column right here, or this row right here, because it's given that the sample does not contain HIV. Okay. So for this one, now I'll explain the process. So we want to know, because false positives are possible, they're going to give you one test first, and if you test positive on that, they're going to give you 2 more. If of those 2 more you get at least 1 positive result, then you're subjected to the more expensive testing. So the ways there are, if you don't have HIV, for you to get the more expensive test, you had to get test positive the first time. So I have test positive the first time on all 3 of these. After that, you have to get at least 1 more test positive. So you could have gotten 2 more tests. You could have gotten the first or the second one positive, the third one negative, or the second one negative and the third one positive. So now when I look at my test positive, remember I'm only looking at the ones with HIV, so this is 37 over 500. For my test negatives, that's 463 over 500. And then when you put all of this together, you should get 0.0105. Alternatively, there's the other option is to say your first test has to be positive, and then we need at least 1 more positive test. As we know, at least 1 more positive is the same thing as 1 minus no positives. So you can do it like this. So I can start with, I have to start with a positive test, and then I need at least 1 more to be positive. So I just did 1 minus the probability that they're both negative, and that'll give me 0.0105. So let's look at the scoring. Essentially correct if the student computes the correct probability showing work. Partially correct if method is equivalent to P first ELISA positive, at least 1, 2 is positive, except that one of the factors is incorrect. So that's what I did. I did something that's equivalent to that, but one of my factors was incorrect. So this will be a partially correct. Or if you forgot to include the first one, so if you did this essentially, without that first fraction in there, that was also a partially correct. Or if you did binomial and you said you want at least 2 successes out of 3 trials, but you didn't take into account that the first trial has to be positive. So if you just treated it as if there were 3 different ones and you wanted 2 positive results, that can also get you a partially correct. That equivalent answer would be 0.0156. Incorrect otherwise. So read through these. It looks like it's the same as usual. I have 2 E's and a P, so this is a 3 out of 4. And again, this is why we check our answers, because even Ms. Nichols makes mistakes sometimes.